Well, welcome. This is the solution for the IM1 Honors Module 1 review packet. We're going over the solutions. This is the third video. This is going to be covering the last parts, the part 9, part 10, part 11, and part 12. Okay, so two numbers of the sequences shown. Notice that they all start the same, which is 2, 8. Ashley believes the sequence is arithmetic, and George believes that the sequence is geometric. Okay, so pick out the appropriate two numbers for each sequence from the option bank. So arithmetic, that means you have to compute the common difference. The common difference here is 6 because that is how you go to the next term. 8 subtract 2 is also 6. So here I write it out. So the first term was 2, the second term was 8. The third term is 8 plus 6 because again you're adding the common difference. The fourth term, again you're adding the common difference again, so it becomes 8 plus 12. So 8 plus 6 is equal to 14, and the fourth term, 8 plus 20 is equal 8 plus 12 is equal to 20 as the fourth term. Geometric, you would say the common difference here is 4. So because 8 divided by 2 is 4, that is how you get the common ratio of 4. The first term here would be 2, the second term here would be 8, the third term here would be 8 times 4, and the fourth term would be 8 times 4 squared, which is 16. Okay, so 8 times 4 is 32, and 8 times 16 is 128. Okay, so here, what this is right here, some of you might have the question, this is just the recursive. This is just writing out the recursive, okay, to see the pattern. All right, that's basically the usefulness of the recursive, is just to see the pattern. 10. For the following function, write in recursive formula. In the recursive formula, okay? Here, the first term is 7 to write out the equivalent explicit. So here we know that this is how the explicit, one version of the explicit for the arithmetic sequence looks like. So we need to get the common difference. So the common difference is right here. Okay, because again, it is add the common difference. So the common difference here is -2. And you plug it in. So the first term here was 7 and minus 1 plus, oh, should it not be plus? Wait. This is correct. Give me a second. This would be multiply -2. Is that right? Yes, that would look right. Yep. Because if you write out the other version of it, okay, it would look like this. In f of x notion, it would look like this. Plus 2, so it's like this. So yeah, that's right. Make sure you multiply here. I wrote it here, multiply. Okay. I don't know. This is the explicit, but here you multiply right here. So this is the geometric. So this is the first term, geometric, because we have the first term here. Looks like that. The first term was 5. The r here was -3. Okay. So the r here was -3 because you get it right there. Okay. Plug it in. This is considered the first term, explicit. Good? Alright, part 11. Isabel starts her training, running 2 miles in 1 hour. Isabel records how far she runs in an hour for every single 2 weeks. Okay. If you look at this, do you see how from here to here, it's not constant, right? Here you're going up by 0.04, then you're going up by, what's the next one, right? 4.08. Okay, it's not consistent, so it's not arithmetic. There's no constant rate of change. So I computed the common ratio. Second term divided by the first term. Get you r equals to 1.02. You would say that the r is equal to 1.02, or you could say it is a growth of 2%. Either one works, okay? Having an r of 1.02 means you have a growth of 2%. Same thing here. George deposits $5,000 into a savings account to save for college. Based on the interest rate of the account, George computes the value from year to year. Here, if you look at the calculations from here to here, it is a $1,000 increase. Here, it is a 1,200. It is not constant, so that's where I will assume it is a geometric sequence, which is going to have a common ratio. So I'm going to compute the common ratio. So I did 600 divided by 500. I get R is equal to 1.2. So I see here that the growth has a common ratio of 1.2, or you could say that the growth here is 20%. Again, how did I get that? If some of you are curious, you know the 0.2 here, 0.20 in percentage form is just 20%. That's how I got growth of 20. Right? Okay. Part 12. The current bacteria population on a toothbrush is 20,000 micrograms. Okay, and the bacteria population is expected to grow at a rate of 3% per hour. Which of the following function represents the expected bacteria population on the toothbrush, where T is the number of hours that have passed since the current hour? Please make sure you understand that the first term here is 20,000 because nothing has happened. Also, you can look at the word current. Okay, that indicates the f of 0. You could also see the word initial. Okay, and then the R would be considered 1 plus the rate of change. How do you know that? Because here it says expected to grow, so that is a 1 plus. This gets you in decimal form as 0.03. That is how I get the R value of 1 plus 0.03. So the common ratio is 1.03. Plugging it into the zero term explicit, it would look like that, which would be 20,000. The R is 1.03 to the exponent of T. Next, you could read the scenario here. The current mass of a decommissioned nuclear warhead is 110 grams, and the mass is expected to decay at a rate of 7% per million per mass per billion per year. Okay, so the current mass, we should already know that. It says the word current, so that gives us our first term, 410 grams. Okay, decay, that means it's a 1 minus 7%, which is 0.07 in decimal language. So R equals to 1 minus 0.07. You get R equals to 0.93. You have the zero term and the common ratio. Just plug it into the zero term explicit for the geometric sequence. You get C, which is your final answer. Alright, so there you go. Those are all your solutions.